Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from May June 2023, paper 1, variant 2. As always we will discuss these questions in detail so you can improve your conceptual understanding of AS physics, and also you can have better understanding of these questions. Let's study together, let's improve together. In today's lesson, we are talking about May June 2023, paper 1, variant 2. And total time for this exam is 1 hour and 15 minutes, and you need to answer all questions on this paper, and there are total 40 questions on this paper, and total mark for this paper is 40. On the second page of your exam paper, you can also find some important data, and also some important and basic formulae are also given to you. In the exam, if you need value of any constant, or if you have forgotten any formula, you can come to the second page of exam paper and you can find values of constants, and also you can find some important formulae. Question 1 says a stone sinks in water. What is a possible value for the density of the stone? So first of all, we can simply imagine we have a beaker, and this beaker is filled with water, mean we have some water inside this beaker. And now if we place a stone at the surface of the water, this stone will simply sink. So stone will stay at the bottom of the water. As this stone sinks, it simply means that the density of the stone has to be greater than density of water, and density of water is equal to 1000 kgs per cubic meter. Now if you look at given options, for option A it is given to us 8 times 10 to 2. It simply means that this is 800 kgs per cubic meter. If this is the density of the stone should float at the surface of water. If you look at second option, this is 2000 kgs per cubic meter, and this density is greater than density of water, so it means in this case stone will sink if this is the density of the stone. So this can be our possible answer. But if you look at option C and D, units are newtons per cubic meter. So here we have newtons per cubic meter, here also we have newtons per cubic meter. So we can check these units. Are these units of density or not? Newtons per cubic meter, so we can write down this is newtons. We have per cubic meter, and for newtons SI base units are kgs meter per second square, and this is meter cube. So if we simplify this one, we can write down kgs. We have meter here, so this is m to the power of -3 and s to the power of -2. So we can write down this is kgs, m to the power of -2, s to the power of -2. And these units are not units of density. So it means option C and D, they are not possible answers. A is also not possible answer. So the answer for question 1 is B. Question 2 says gigameter, terameter, micrometer and picometer are units of length. Which unit is the largest and which unit is the smallest? So simply we need to understand the meaning of prefixes. So first one we have is gigameter. G is representing giga, and 1 giga is equal to 10 to 9. Next one we have TM, means terameter, and T is representing tera, and 1 tera is equal to 10 to 12. Next one we have is micrometer, and mu is representing 10 to -6. Next one we have PM, and P is representing pico, 10 to -12. Question is simply asking you which one is the largest. So tera is the largest, means this one is the largest one, and this one is the smallest one. So we have largest, this is the largest, this one is the smallest. So the answer for this question is D. Question 3 says two measurements for a solid sphere are shown. Mass is given to us, diameter is given to us, and the absolute uncertainties are also given. These values are used to determine the density of the sphere. What is the percentage uncertainty in the density? So first of all, we need to understand density is equal to mass over volume. So the percentage uncertainty in density we can write down delta rho by rho multiplied by 100. So this is the percentage uncertainty in density, and this one has to be equal to the percentage uncertainty in mass. So we have percentage uncertainty in mass here plus percentage uncertainty in volume. So we have absolute uncertainty divided by the volume multiplied by 100. For the mass, we can simply write down, we have the absolute uncertainty, we can divide this one by mass, multiply by 100, we can calculate percentage uncertainty in mass. But percentage uncertainty for volume is a bit tricky. So first of all, we can write down volume of a sphere. This is equal to 4 by 3 pi r cube. But in this case, we have diameter instead of radius. So we can say 4 by 3 pi. So here we have diameter. We can say this is d by 2, means this is equal to radius cube of this one. Now, if we simplify, we will get 4 pi d cube divided by, we have 3 here and we will get 8 here. Now we can cancel this 4 with it. So we left with pi by 6 d cube. So this is the volume. But if we look at this one, pi over 6, this is constant. So when we calculate percentage uncertainty, we don't consider constant numbers because they will be simply cancelled. So we can write down delta v for v from here. This one has to be equal to delta d by d, and if we are calculating percentage uncertainty, we can also multiply this one by 100. So let me rewrite this part again. So to calculate percentage uncertainty in volume, simply what we need is delta v by v multiplied by 100. This one has to be equal to delta d by d multiplied by 100 and multiplied by the power of d. So it means we can simply replace this one with this. We can rewrite here. So we have, this is delta m by m multiplied by 100 and plus we have 3 times we have delta d by d multiplied by 100. Now simply we need to plug in values. So we have absolute uncertainty. This is representing delta m and this is representing delta d. So we have 0.1 divided by 32.5 multiplied by 100 and we have plus, we have 0.04 divided by 1.87 multiplied by 100. Now simply we need to solve this one. If we solve this one, we will get 6.72. Percentage uncertainty should be written up to 2SF. Up to 2SF. So our final answer has to be 6.7. So the answer for this question has to be D. Question 4 says an aircraft travels along a horizontal path. Two of the forces that act horizontally on the aircraft are thrust force of the engines and the force due to the wind. The vector diagram for these forces is shown in this figure. Which factor represents the resultant horizontal force acting on the aircraft due to these two forces? So we have force due to the wind, we have thrust force of the engines. Simply we need to find the resultant force. In order to find resultant force, simply we can use parallelogram method. Means simply we can take this vector, we can place at the tail of this vector. So it has to be parallel. So this vector is little bit slanted down, so it has to be parallel to this vector. So these two vectors are almost parallel. Now we can take the second vector, we can draw at the head of this one. So these two vectors also have to be parallel, this one and this one. Now simply we can draw the resultant. So the resultant of these two has to be from the tail of these two to the head of these two vectors. So this is our resultant. So simply we can use letter capital R for this. So the answer for this question has to be C. So C is the correct. Simply you have to use parallelogram method and you can find the resultant force. Question 5 says a ball travels from point X to point Y around a semicircular track of radius 1.0 meter as shown. What is the displacement of the ball from X to Y? So for this question we need to understand this is our initial position, then this one is the final position, and displacement is the shortest distance between initial and final position. It simply means that this is over displacement. So this is displacement. This is semicircular and the radius of this one is r. So it means this distance, this has to be equal to 2r. So simply we can say in this case d, this is equal to 2 times r. So it means this is equal to 2.0 meters, and direction of this one is due south. So this is due south. So the answer for this question has to be B. Displacement is a vector. Question 6 says a rock is launched vertically upwards from the surface of Earth. An identical rock is launched vertically upwards from the surface of Mars. Each rock is launched with an initial velocity of 12 meters per second. Each rock reaches its maximum height above the surface before returning back down to the surface. The velocity time graph for each rock is shown. In both cases, air resistance is negligible. We need to find out the difference in the maximum heights of the rocks. So first of all, we can sketch. We can imagine this is our beautiful planet. And from the surface of our beautiful planet, we throw a rock. And the initial velocity of the rock is given, that is equal to 12 meters per second. This rock will go up and then it will come down to the surface of the planet. We can also assume we have Mars here. So we are standing at the surface of the Mars and we throw a rock, identical rock. And the initial velocity of this rock is also 12 meters per second. This rock will also go up and then this will come back. The height they will reach, maximum height will be different in these two cases, and we need to find the difference in height. Now if you look at the velocity time graph, this is for our planet. So at this point velocity becomes 0, means when it reaches at the maximum height, v is equal to 0. So this is the height. So simply we can say this is the height. So this one is the height. And we have velocity time graph. It means this area under this velocity time graph, this is representing the height. So if you look at the time, here time is equal to 1.2 meters. And for the Mars also this is true. When the rock reaches the maximum height, its velocity will be equal to 0. So this is the height. So this one is the height. So we can say this height is he, and this height we can say this is hm. Now if you look at the velocity time graph, we have for the Mars until this point. So velocity here is equal to 0 and this time is equal to 3.2 seconds. So it means we need to calculate area under this line. So this total area is representing the maximum height reached by the rock above the surface of Mars. So simply we need to calculate areas. So first of all, we can calculate he, height above surface of our planet, and this one will be equal to, we have 1.2, so here we have 1 by 2. 1.2 means this is the base and the height is 12. And if we solve this one, we will get, in this case, this is equal to 7.2 meters. Now we can also calculate for the Mars. We can say this is hm. This will be equal to 1 by 2 and the time we have, that is equal to 3.2 seconds, and the initial velocity, that is 12. If we solve this one, we will get 19.2 meters. So we need to find the difference, delta h. Delta h will be equal to hm minus he. And if we solve this one, we have 19.2, we have minus 7.2 meters. So we will get, this is equal to 12 meters. So the height difference is equal to 12.0 meters. 12.0 meters. So our final answer for this one has to be A. Question 7 says, which statement describes the mass of an object? And mass of an object, simply we can say mass is inertia of a body. Higher the mass, higher the inertia of the body. Or we can say mass opposes change in velocity. Opposes change in velocity. But in a very simple language, you can also say mass is amount of matter in a body. Amount of matter in a body. In a very simple way, we can say amount of matter in a body. So we can say this is also represents mass. But if you look at given options, it is given to us the force the object experienced due to gravity. No, this is the weight. So this is not right option. So this is not correct. Momentum of object before a collision. So this is just representing momentum. So this is also incorrect. Resistance of the object to changes in motion or change in velocity. So this is correct. So this can be the answer. The weight of the object made by a balance. No. So this is also incorrect. Weight, mass and weight, they are two different quantities. So the answer for this one has to be C. Question 8 says a submarine of total mass 3200 kg is at rest under water. The total mass of the submarine is suddenly decreased by 200 kg by pumping water out of the submarine horizontally in a negligible time. The upthrust acting on the submarine is unchanged. Upthrust is unchanged. The change in the total weight of the submarine causes it to accelerate vertically upwards. What is the initial upward acceleration of the submarine? So we have two different cases. First of all, we have case 1. So simply we can say for case 1, it is given to us submarine is just simply at rest. And the weight of the submarine will be acting downwards, and weight of the submarine will be equal to mg. So simply we can say this is equal to mg. And mass of submarine is given to us, that is equal to 3200 kgs multiplied by value of g, that is equal to 9.81. As submarine is at rest, it's not moving vertically up and not moving vertically down. It means the upward force, the upthrust, this is also equal to mg. So we can say upthrust is also equal to this, and this is equal to mg. So this is case 1. Now if you look at the second case, for the second case it is given to us, we have weight of the submarine. Weight of the submarine is acting downwards, and weight of the submarine is now equal to 3000 times 9.81. Mass has been decreased by 200 kgs, but upthrust remains unchanged. So we can draw arrow for upthrust. So upthrust remains unchanged. So upthrust in this case is greater than weight now. Upthrust is equal to 3200 times 9.81. In this case, acceleration is equal to 0, but in this case, submarine will accelerate vertically upwards because upward force is greater than downward force. And we need to calculate A. In order to calculate A, simply we can write down here that A has to be equal to the net force on the submarine divided by total mass of the submarine, m total. And net force is the difference between these two. So we can write down 3200 minus, we have 3000, and this one we can multiply with 9.81 divided by, this has to be divided by 3000. This is the mass of the submarine. Now if we solve this one, our answer should be equal to 0.654 meters per second per second. So the answer for this question is B. A beautiful question, how to apply Newton's second law of motion. Very nice question. Question 9 says a box in A slides with increasing speed down a rough slope from point P to point Q. The slope surface exerts a constant frictional force on the box. As the box moves from P to Q, there are changes to the magnitude of its acceleration and total resistive force acting on it. Which row describes the changes? So for this one, first thing we need to understand, as the box is moving down, speed of the box is increasing. So as the speed of the box is increasing, so we can write on speed. So the effect of air resistance has to increase because air resistance depends on it depends on speed. If the speed increase, air resistance will increase. You can also simply imagine it is moving in the air. So here are air particles. So you can also imagine there is a sea of air. So it is moving in the air. So as this box is moving in the air, it will hit air particles. For example, if I imagine there is a particle is here, air particle here, this box will apply force on this air particle to the right, and this air particle then as a reaction it will apply force on this box to the left. If this box hit harder air particles, it will exert more force on air particle, so the reaction force on the box also will be greater. And so that's the reason as speed of the box increases, air resistance also increases. As air resistance increases and friction remains constant, so simply we can say the resistive force, total resistive force increases, because total resistive force is the sum of friction plus air resistance. Air resistance increase, it means total resistive force increases. As total resistive force increases with time, with speed, so what is the effect on acceleration? So we can draw the forces acting on the box. So there is one force, that is mg is acting vertically downwards, and there will be normal reaction force, that is normal to the surface. We can simply say this one is n, and there will be resistive force on the box. We can say this resistive force is Fr, simply we can say. And also we can assume here is the angle theta, and this angle remains constant, so we can resolve weight into two components. We can draw this arrow bit longer, so this is the weight, so we can resolve into two components. This angle also has to be theta if this angle is theta. So this component of the weight is acting vertically downwards, so this component will balance normal reaction force, and this component of the weight has to be mg cosine of theta, because this is with angle. This component of the weight that is down the slope, this one has to be mg sine of theta. So in this case, along the plane we have mg sine of theta minus we have Fr, and this is equal to ma. In this case, as Fr is increasing, so Fr is increasing, but this one is constant, so it simply means that A has to, this is mass is constant, so A has to go down because the net force is decreased. So simply we can say acceleration will decrease. So acceleration is decreasing with time, but the speed is increasing, so acceleration is decreasing with time. How about the resistive force? Resistive force is increasing. So if you look at the given option, resistive force increases, so this can be possible, but this one has to decrease, so this is not possible. Resistive force increase, yes. Acceleration decrease, yes. So if you want to write down acceleration here, you can also write down like this. So acceleration is equal to mg sine of theta minus Fr divided by mass of the block. So this is mass of the block. As this is constant, this quantity is not changing, but this quantity is increasing, so it means this has to decrease. So that's the reason answer for this question has to be D. Question 10 says two balls x and y approach each other along the same straight line and collide. The collision is perfectly elastic. Their initial speeds are u sub x and u sub y respectively. After the collision, they move apart with speed vx and vy respectively. Their directions are shown in this figure. Which equation is correct? In order to answer this question, first of all, imagine that we have one ball x. Let's say this is ball x, and here we have one ball y. Let's say x is moving to the right with velocity u1 and y is moving to the right with velocity u2. And after collision, x continue moving in the same direction with velocity v1 and y continue moving in the same direction with velocity v2. But in this case, u1 is greater than u2, so this is very important. u1 is greater than u2, so they will collide with each other. Now for this case, you need to understand, as this is perfectly elastic collision, it simply means that relative speed of approach, as this is perfectly elastic collision, so relative speed of approach should be equal to relative speed of separation. Relative speed of separation. this is only true if collision is perfectly elastic. So for this one, the relative speed of approach is u1 minus u2. In this case, we are taking to the right is positive, and for this part, relative speed of separation simply will be equal to v2 minus v1. And this is very simple case, and we can extend this case to this one as well. So in this case, again we will take to the right is positive, to the right is positive. So we can write down in this case u1 minus u2. This one has to be equal to v2 minus v1. Means the relative speed of approach, it has to be equal to relative speed of separation. So in this case, we are taking to the right positive. It means this velocity is positive, but this one is negative. This one is negative, and this one is positive. So u1 is ux, so this is positive. u2 is uy, but this is negative. So negative means positive. So simply we can write down this will be positive. v2, we have this is means vy, so simply we can write down this is vy minus, and this one is negative, so we have minus vx, minus vx. So simply in this case, finally you will get ux plus uy, this is equal to vy plus vx. So this is the relative speed of approach, and this is relative speed of separation. So we can say this is relative speed of approach, and this is relative speed of separation. So next time you don't need to write down the first part. You don't need to do this part next time. Simply you can remember this, and then you can follow this sign convention, and you can answer this type of problems. So this is the main idea, how to answer perfectly elastic collision questions. In today's lesson, we have discussed first 10 questions, and I will try to upload remaining questions as soon as possible. See you in next video.